Good morning, all of you. Now I am going to discuss about pulse modulation. This pulse modulation is divided into analog modulation and digital modulation. Under analog modulation, there is PAM, PWM, PBM. PAM stands for pulse amplitude modulation, pulse width modulation, pulse position modulation. And this is PCM is pulse mode modulation. So let us discuss one by one now. Coming to the pulse amplitude modulation. So in the name itself it is indicating you are modulating the amplitude of the pulse. So that is called the pulse amplitude modulation. In this main pulse modulation, the carrier wave is in the form of pulses. So the carrier wave is a train of pulses. So in this pulse amplitude modulation, the modulated signal is combined with a train of pulses to get the output modulated signal. So here the amplitude of each pulse is controlled by the instantaneous amplitude of the modulation signal. So in this modulation system, the signal is sampled at regular intervals and each sample is made proportional to the amplitude of the signal at the instant of sampling. So here you can observe in this waveform. So this is the given input signal, analog signal. For this you are providing a carrier sample signal so that the output will be like this. See here, at this point the amplitude is more, the magnitude is more. So relatively you need to mention the pulse with having highest amplitude, and here you are having lowest amplitude. So here you are giving 0. And here meanwhile you can give different small pulses also. So these are nothing but pulses. So this is the positive waveform. Likewise in the negative waveform also, this is the negative maximum and negative small peaks. Here it will be minimum again. This point and this point, here the amplitude is minimum. Whereas here and here the amplitude is maximum. So likewise you are creating a pulse amplitude waveform. This is the amplitude modulated pulses. Or else this can also be mentioned as, in the positive waveform you can mention like this, and here the magnitude is minimum, you can consider like this, and you will be getting only the positive cycle here, positive pulses only. So in some modulations there will be only having positive pulses, so that you will be having only positive pulses here. So here you are observing both the positive pulses as well as the negative pulses. So this is called pulse amplitude modulation. Next one is pulse width modulation. In this pulse width modulation, pulse width or pulse duration modulation it is also called. So in this modulation, the samples of the message signals are used to vary the duration of the individual pulses. So the message signals are used to vary the duration. That is, the duration indicates the pulse width of the individual pulses. So this can be explained by this waveform here. As the amplitude is more here, the pulse duration is more here. You can observe here. So the pulse duration is more. Whereas here, coming here, the pulse it is having minimum amplitude, so you need to indicate the minimum pulse duration. Here it is maximum and here it is minimum. In between you can mention the some lesser values. So here it is more, somewhat less it is the next pulse, and somewhat less it is the next pulse, and this is the minimum pulse, so it is having minimum pulse duration. So likewise it is indicating the amplitude magnitude in terms of the width. So this is called pulse width modulation. And next, coming to the pulse position modulation. So in this pulse position modulation, the position of the pulse is to be indicated here. So this position of the pulse related to its unmodulated time of occurrence is varying in accordance to the message signals. So in this waveform, you can observe uh, either a trailing pulse or leading pulse. Suppose this pulse position modulation has to come from the pulse width modulation signal. Suppose this is the pulse width modulated signal. This is the starting end and this is the trailing end. So at the starting end you are giving the pulses and at the trailing end negative pulse. Positive end positive pulse and negative end negative pulse. So this is indicating the uh, starting and ending of each of the pulses positions. So this is called pulse position modulation. Okay. This is about the analog modulation. So in the analog modulation, there are three types of modulation. Those are pulse amplitude modulation, pulse width modulation, and pulse position modulation. So these are all about the pulse and analog modulation. Next one is digital modulation. Under digital modulation, there is pulse code modulation. So here in this modulation, you need to finally come up with the pulse code. You need to generate the pulse code. How you are going to generate is discussed now. So in this modulation, the pulse modulated signal first is converted into certain code format. It is converted to certain code format. How it is going to be converted is first the modulated signal is sampled by the carrier signal. So the modulated signal is sampled by the carrier signal. After sampling, the sampled signal is quantized. What is the meaning of quantization? So quantization is nothing but it is dividing the amplitude into several levels. It is called the amplitude into equal several parts is nothing but the quantization. The quantization signal that is fed to the analog to digital converter so that you will be getting a digital code. So finally you need to get this code. Digital code indicates either ones or zeros. So here you can observe in this waveform. So initially the signal which you are considering is this one. So this is to be sampled now. Sampled means for each part of time it should not be continuous. It is indicated as a dotted line. For each point it is sampled. This is the sampled signal. And after sampling what you need to do? You need to obtain the quantized signal. So what is the meaning of quantization? Quantization means you need to divide this amplitude. This is the amplitude here. This is QP is the positive peak and minus QP is the negative peak. And this is to be equally divided into parts. This amplitude is equally divided into parts. And how much what is the length of this part is how can you calculate it? Suppose L is the number of levels. L is the number of levels and 2QP is the peak to peak amplitude. Then you can get the magnitude of each level that is equal to 2QP by L. 2QP by L is the length of each amplitude. So this is the finally quantized signal level. So this is given to the ADC, A to D converter, A to C converter, that is analog to digital converter, so that you will be obtaining the digital code. So this can be explained with a block diagram also here. So this is the block diagram of the pulse code modulation. In this pulse code modulation, first you are providing the analog signal. So this analog signal is given to the sampling system. So what does the sampling system is? Does is it will sample the analog signal. Analog signal after sampling this is given to the quantization. Quantization means it will be getting the you will be dividing the amplitude into several levels. So this is the quantized signal. So at this point of time you are getting the sampled signal and at this point of time you are getting the quantized signal. After quantization it is given to the encoding. Encoder consists of a to D converter so that you will be getting this analog signal into digital signal. Digital means it will be in the form of ones and zeros. This is the digital data. This is how you can transmit this data by using the pulse code modulation technique. Okay, so that is about the pulse code modulation. So overall, we have discussed about these are the different types of modulations. So in that, continuous modulation and pulse modulation are there. Under continuous modulation, we have discussed about the amplitude modulation, frequency modulation, and phase modulation. Under pulse modulation, we have discussed about pulse amplitude modulation, pulse width modulation, pulse position modulation. And under digital modulation, we have discussed about the pulse code modulation. So these are the different types of modulation.